All right, so we're going to take a look at how to use Desmos to factor and to solve quadratics. Again, remember, factoring means that your answer is in factored form. It looks like that in parentheses. And solving means that you have x equals blah, blah, blah. You found the x-intercepts, the roots, the zeros, or the solutions. Okay, note, this only works if the answer is rational. So let's remember, what does rational mean? Rational means that the answer can be written as a fraction of integers, written as a fraction of integers. And go ahead and squeeze this somewhere on your paper. So one, fraction of integers. Number two, repeat in decimal, and three, terminate in decimal, terminate in decimal. All right, so just write that just as a note, because this only works for that. It does not work if it's irrational, okay? All right, so here are the notes. We're going to combine any like terms. So here's my question right here. We need to write a new expression to where we combine any like terms. And really, I should say combine any like terms and set to 0 and set to equal 0. Okay, so I need this to equal 0. So what I'm going to do is I'm going to take this to the other side by subtracting 24. Once I do that, I'm going to get 6x squared minus 18x minus 24 equals 0. So the important thing is you do need to write it in standard form. It does need to be equal to 0. Okay, so it says solve, and that's where it crosses the x-axis. So divide each term by the greatest common factor. So you're looking here, right? What is the greatest common factor between 6, 18, and 24? So that's what we need to find. All right, so we're going to use the calculator the whole time to find out what the greatest common factor is. And we're going to write notes here. So to find the greatest common factor in the calculator, you're going to literally type GCF, greatest common factor. And then let's see what we need to do. Try using parentheses. Okay, so greatest common factor of what numbers do I want? 6. All right, so 6. All right, I also want negative 18. All right, and I also want negative 24. And boom, it's telling me the greatest common factor of these three numbers is 6. So we're going to put some notes here for number 2. We're going to put in the calculator GCF, parentheses, and then your numbers separated by commas. Okay, so you're saying in Desmos, let's make sure we say in Desmos. All right, put GCF, parentheses, comma, comma. So it's telling me the greatest common factor here is 6. Okay, so we're going to rewrite this. And I think I was supposed to rewrite that over here, but it's okay. I'll write it above. So greatest common factor is going to be 6. So what happens when I take 6 out? And I'm just going to use the calculator. So when I take 6 out of the first one, right? So 6 divided by 6 is going to be 1. So that's going to be, the expression there is going to be 1. Let me change my color. So this first one's going to be x squared. Okay. Then what happens when I take out 6 from negative 18? So negative 18 divided by 6, because I'm taking it out, is going to be negative 3. So x squared minus 3x. And there's a 6 outside here. Sorry. All right. 3x. And then I take it out from negative 24. Negative 24 divided by 6. It's going to be negative 4. So negative 4. Equals 0. So I've taken out the greatest common factor, which is 6, which leaves this. Then it says type the new reduced expression into Desmos. Now, to make sure that I've got the exact expression, what I'm going to do is I'm going to actually start with the original. 6x squared minus 18x equals 24. To make sure my reduced one is correct. So I have 6, and if it's correct, it's going to match, right? So x squared minus 3x minus 4, all right, equals 0. Okay, and I'm just gonna, so I have purple, and if it matches, goes right over it. Yep, it does. For whatever reason, when you don't put the equal 0, see, it doesn't match because this is expression is not the same as an equation. So make sure you put the equal 0 to check that it does match. So perfect, that matches. I factored that out correctly, so I'm good. Type the new reduced into Desmos. That's what I just did right there. Then it becomes by inspection. Okay, so example 1, 2, and 3 that we did above. So follow those steps. So all I'm looking for, right, if I'm trying to solve for quadratic is where I'm looking for this x-intercepts, the roots, the solutions, or the zeros. And if I'm trying to factor, I do one step after this. So solve where it crosses the x-axis. So it crosses the x-axis at -1 and 4. So this is -1 and 4. Okay. Then factor, opposite sign, and solve in parentheses. So do remember, right? In order to make this into factored form, you do the opposite sign. So this is +1 and this is -4. All right, and the reason we do that, so don't write this down, I'm just going to show it to you real quickly. If I take x plus 1 equals 0, you take this to the other side, it's going to be -1, so x is equal to -1. That's how we get from solution to factored form. Okay, so you don't need to write that part down. All right, so we've done the first example. So when it's rational, you can use the calculator to do it. So I'm going to go do example 6, and then you guys are going to do example 5. All right, so again, combine any like terms. There's nothing on the other side to take it over. Divide each term by the greatest common factor. So we're going to go ahead and put in the question because, again, the question is going to let us know if we're on the correct track while we are working on it. That way we can fix our mistakes as we go. All right, so that's the question. This is the answers already right here, but we do have to follow these steps in order to get the factored form. All right, so it says divide each term by the GCF. All right, so again, to find GCF in the calculator, you go GCF. Then if you forget, just click on here. It says try using parentheses. Okay, so what do I want the GCF of? I want the GCF of 12. I want the GCF of -68, and just separate them by commas, and the GCF of +40. So the GCF is 4. That means I'm going to take 4 out, and what do I have left with, right? So when I divide by 4, what do I have left? So I take my first number, and I go 12 divided by 4. It's 3. So here I have 3x squared. Okay, then I have the next number, and because I took out +4, nothing changes, so this is going to be minus. And if I put it in here, you'll see it as a -68 divided by 4 is -17x. All right, so all I'm doing is dividing by 4 because I'm taking it out. I'm factoring it out. Last one is 40, +40. So +40 divided by 4 is +10. So this is going to be +10. And again, you need to make sure that it matches exactly as you go. So this is correct, which means I've taken out the GCF correctly. So this is my new expression. I can go ahead and write it down. So my new expression, and don't forget this 4 outside. It's very important. All right, so 4, and then we have 3x squared minus 17x plus 10 equals 0. So we're going to keep the equals 0 there. All right, so actually equals 0, I'm supposed to put equals 0 here. And again, I want to just go ahead and point this out. Why does it look different? Because this is an expression and this is an equation. Okay, they're two different things. That's why you have to put the equal 0. All right, so now it matches. All right, then it says solve where it crosses the x-axis. All right, so type in the new reduced into Desmos. I have. It becomes by inspection. So now we're just inspecting. So here are my x-intercepts, my roots, my solutions, my zeros. Okay, so one of those 4 words will determine what you're looking for. All right, so it looks like I have a whole number, which is 5, so that's easy. Okay, so this one where it crosses, x is equal to 5, but it also crosses where x is 0.666. Now remember, I said this only works if the answer is rational. Is this a rational or irrational number? Well, I can see that it's repeating, and what Desmos has done is they don't feel like writing 6666666 forever, so they just rounded the last 6 that they wanted to write. So let's just see what this would be. So it's 0.66, and then it's a repeating decimal. So we're going to click this real quick. So 66, this does not make sense. Whoa, no. What we're going to do, so sometimes the decimals will be rounded by decimals, but it can still be a repeating decimal, and that would make it rational. So for example, if you have 0.667 turned into a fraction, is this, and this does not look right. That 7 is this 7 is rounded, so you can type in 6666. The function will appear, the fractions will appear, and it looks wrong. So keep trying 6, it will disappear and appear again. All right, so keep trying 6, it disappeared, and then they said it will appear again. So if yes, it did. Now that looks better. So 2/3. All right, 2 divided by 3 looks like a better one. All right, so to find the solutions, you don't have to find the GCF. Where you really have to find the GCF is now when you're trying to do the factoring, because what has happened is this answers here are just for these parentheses. It does not take into account of this, because if you were solving this equation, you would divide by 0 divided by 4 is 0. So the calculator doesn't know that there was a 4 out here, which is why it's important for you to take the GCF so that the factoring can be correct. All right, so you already have a 4 outside, so you need to put that 4 out here. Then everything inside the parentheses is what becomes these two parentheses. So we have x is equal to 5. And remember, when you're factoring, the opposite sign of solve is in the parentheses. So this is positive 5, so this will be negative 5. What happens when you have a fraction, though? You remember that you need to take the denominator to in front of the x. So this is going to be 3x. So this is going to be 3x. Okay, and then the opposite sign, minus 2. And we're going to double check that. So as long as it lines up with all of these lines, it's okay. So we're going to go 4, x minus 5, parentheses, 3x minus 2. Okay, and again, why is it off? Because this is an expression, but what we have in our questions? Equation. So you have to put equals 0. And as soon as I put equals 0, what do you notice? The black line is the blue line. You can long click this color. If you press your mouse and long click it, so we can change it, so we can match it to everything. I'm going to take off the blue one real quick and put the black one on. Does it match the black one? Yes, it does. Exactly. So it matches all of my answers, which means that this answer is correct. So again, the important part of this GCF doesn't matter when you're finding just the solution, the x equals and the x equals. It matters when you're finding the parentheses, the factored form. All right, so we're going to take a look at how do I factor a negative quadratic. As you can see, this negative is right here. So you still follow the steps that you were following before. So first it says combine any like terms. There's nothing to combine. Divide each term by the GCF. So once again, GCF, you're just going to type it in the calculator, GCF, and then you're going to put, the first one is -1, comma, because there's an invisible one right there, 12, comma, -35. All right, so the GCF is 1, so there's nothing to GCF. So we're going to go to the next one. Type the new reduced expression into the Desmos. So again, it didn't reduce, so we're going to just type in exactly what it is. So that's -x squared plus 12x minus 35. All right, so once you type that in, it says, then it becomes by inspection. All right, so it's by inspection, so we're looking. So these are my two solutions. So we have x is equal to 5 and x is equal to 7. So when you're doing a negative quadratic, the solutions don't matter because that's right in the calculator. It's just the quadratic. So we can see that our quadratic is going like this. And if you draw my smiley face, right, is that a happy or sad quadratic? It is a sad quadratic because this negative right here makes it a sad quadratic, which means when you are writing your answers in factored form, so we're going to go ahead and write it. So if you were answering it like before, then it becomes by inspection, so follow those steps. So you're just looking at it and doing the opposite. So let's see, it's 5 and 7. So we're going to say the opposite of 5 is -5, and the opposite of 7 is -7. And as you can see, something is wrong because it doesn't match. That is because it is a negative quadratic. So when you have these negative quadratics, when you write it out in factored form, all right, when you write it out in factored form, do not forget to put the negative outside. You're going to tell it it's a negative quadratic. And you can see immediately I do that, what happens? It automatically fits. So again, when you're factoring negative quadratics, the only thing that you need to remember is do not forget to tell the calculator that it is a negative quadratic. All right, so that is your quadratic in factored form. And then when it says if the question was solved, that would not change. So if the question was solved, so for the solved question, it would still be x is equal to the intercepts, which is 5 and 7. So x is equals to 5 and x is equal to 7. So that doesn't change. The only thing that changes is the factored form writing. And that's all the work that there is to it. So please go ahead and do example 5.